Namaste children. How are you all? I hope you are fine. So now we will study about a new chapter called Exponents and Powers. Exponents and Powers. You see here the mass of the earth is, see, such a big number. After 5, 9, 7, how many zeros? 22 zeros are there. A very big number, a large number. Similarly, mass of Uranus. Uranus is a planet like our Earth. See here, a very big number, very large numbers. Similarly, the mass of other planets and Sun. The distance between Sun and the Earth, Sun and the Moon, Moon and the Earth. That is Sun and Saturn, the other planets like Uranus, Mars, Jupiter. So they are very big numbers, large numbers. So such numbers, it is very difficult to understand, to compare them, to understand them and to remember such big numbers. It is very difficult to remember and to understand, to write and to read. To read also it is very big. See, how can you read this number? We have, it is a very big number. So to overcome all those difficulties like to read, to understand and to compare these large numbers, exponents are used. Exponential form. These numbers are written in the form of exponents and that form is known as exponential form. So large numbers like a mass of the earth or mass of the Uranus and other planets, the distance between Sun and the Moon, Sun and the Earth. So these distances, these numbers are very large numbers and it is very difficult us to read and to understand and to compare those numbers. So to overcome that issue or to overcome that problem or to make easy, so exponents are introduced. So we can write these numbers in the form of exponents. Now we will discuss what is an exponent, what is exponential form. See, for example, a number. What is this number called? 10,000. So 10,000 can be written as 10 into 10 into 10 into 10. So 10,000 can be written as 10 into 10 into 10. That is 10 is multiplied by 4 times. How many times? 10 is multiplied by 4 times. So this can be written as 10 to the power raised to 4. That is, or simply 10 to the power of 4. 10 to the power of 4. So 10 to the power of 4 is the short form or exponential form of 10,000. Exponential form of 10,000. See here, which number is there? Which number we are multiplying? 10. 10 is multiplied by itself for how many times? 4 times. The number which is multiplied by itself is known as base. So here 10 is the base. 10 is the base. How many times that number is multiplied? That number is known as exponent. So this number is known as exponent. So in the number 10 to the power of 4, 10 to the power of 4, 10 is called the base and 4 is known as exponent. Similarly, 1000 can be written as 10 into 10 into 10. 3 times you will multiply. That is 10 to the power of 3. 10 to the power of 3 or 10 is raised to the power 3. Or simply we also got as 10 cube. 10 cubes. Special names were there for 2 and power 2 and power 3. Power 2 will call it as a squared. Power 3 will call it as a cubed or cube. So this is a 10 cube. 1000 can be written as 10 into 10 into 10. That is 10 to the power of 3. So here again 3 is called what? Exponent and 10 is known as base. As 10 is multiplied by itself for 3 times. So 10 is known as base and 3 is known as exponent. Even if you take 1 lakh, the other number 1 lakh. So 1 lakh can be written as 10 into 10 into 10 into 10 into 10. So like this we will multiply 5 times 10. So 10 to the power of 5 we will write. 10 to the power of 5. So here 5 is known as exponent and 10 is known as base. If we observe these exponential forms, 10 to the power of 4, 10 to the 10 cube or 10 to the power of 5. Here if you observe here, 10 is the number which is multiplied by itself by different numbers. For different numbers. So here 10 is the base, that is common base is there, and here the exponents 4, 3, 5 different exponents are there for same Same base. Not only with the 10 we can write these exponents, with some other different numbers also we can write. See, 16 is there. 16 can be written as 2 into 2 into 2 into 2. That is 2 2s are 4, 4 2s are 8, 8 2s are 16. So 16 can be written as 2 to the power of 4. Here which is the base? 2 is the base and 4 is the exponent. 4 is the exponent. Then not only this with power 2, even 625 is there. 625 we can write as what? 5 into 5 into 5 into 5, that is 5 to the power of 4. Here base is what? 5. 5 is the base and 4 is the exponent. 4 is the exponent. And not only this, even if you take 27, 27 can be written as 3 into 3 into 3. That is 3 3s are 9, 9 3s are 27. That is 3 to the power of 3 or 3 cubed. 3 cubed. So here 3 is the base and this 3 is again exponent. Here base and exponent both are same. Next, if we take 81, 81 can be written as 3 into 3 into 3 into 3. That is 3 to the power of 4, where 4 is the base, 4 is the exponent and 3 is the base. So how we got this 81? 81 we will get it by using what? Prime factorization. That concept we will discuss next time. So 81 can be written as 3 into 3 into 3 into 3, like this is 3 to the power of 4. 27 can be written as 3 into 3 into 3, that is 3 cube. So here this concept, not only for this, even if you take the very big numbers, those numbers will write in the form of exponents, and such large numbers we can write in the form of exponents, then thereby it is easy for us to compare them, to understand and to read those numbers. So here this is the base and exponent. What is base? The number which is multiplied by itself. The number which is multiplied by itself in the exponential form is known as base, and how many times that number is multiplied is known as the exponent. So here 10 to the power of 4. Here 4 is the exponent and 10 is the base. Now here you see here 4 is there. 4 can be written as what? 2 into 2. That is 2 into 2 is equals to 4, which is equals to 2 square. 4 also can be written as minus 2 into minus 2. Minus 2 into minus 2. So minus 2 into minus 2, it is minus 2 whole to the power of 2, that is minus 2 whole square. This is minus 2 whole to the power of 2. Power 2 and power 3 will have special names. Power 2 it is there, we call it as squared. Minus 2 whole square, 2 square, 3 to the power of 3 or 3 cube. Similarly, if you take what it is 81, if you take 81 can be written as minus 3 into minus 3 into minus 3 into minus 3, that is equals to minus 3 whole to the power of 4. In these cases, especially with the negative sign is there, here minus 3, this bracket shows whole, minus 3 whole to the power of 4. Here this minus 3 is the base, minus 3 is the base and 4 is the exponent. 4 is the exponent. Now if I write like this, minus 7 whole square, minus 7 whole square, in this which is the base? Here base is equals to minus 7 and exponent is equals to, what is the exponent? Here it is exponent, it is 2. Now if I write minus 7 square, this is minus 7 whole square. Here if you observe here we have bracket is there for minus and 7 and the square is there, that power 2 is there for both minus and 7. Here minus 7 square is there for only 7. Here base is what? Here the base is equals to 7 and the exponent it is 2. Exponent is 2. Exponent is 2. Like this we can identify the bases and the exponents. Bases and exponents. And we use this concept in solving some of the problems. and we will study this what it is prime factors, prime factorization method to convert the given numbers into prime factors, and their product we can write in the form of exponents, exponential form. So this form is known as what it is, exponential form. Exponential form. Like this we will write this large numbers, this numbers also will write in the exponential form. That is a scientific notation in the last concept of this chapter. I think you can recognize, you can identify which is the base and which is the exponent. Now we will discuss some more numbers which can written, we can write in the form of exponents. You see here, minus 1 square. Minus 1 square means it is minus 1 into minus 1. You know, you have studied integers, how to multiply integers. We will first multiply the arithmetic signs. Minus into minus it is plus. 1 into 1 it is 1 will get. Minus 1 whole cube. Minus 1 whole cube means minus 1 into minus 1 into minus 1. That is equals to, the first step is multiply the arithmetic signs. Minus into minus plus, plus into minus minus. Then 1 into 1, 1, 1 into 1 it is 1. We will get minus 1. So minus 1 whole to the power of 4. Minus 1 whole to the power of 4. You take here minus 1 into minus 1 into minus 1 into minus 1. That is equals to minus into minus plus, plus into minus minus, minus into minus it is plus. So 1 into 1 1, 1 into 1 1, 1 into 1 it is 1. So plus 1 we get. Minus 1 whole to the power of 5. That is equals to minus 1 into minus 1 into minus 1 into minus 1 into minus 1. That is equals to minus into minus plus, plus into minus minus, minus into minus plus, plus into minus minus. 1 1 into 1 1, 1 into 1 1, 1 into 1 1, 1 into 1 1. We will get 1. See, we are getting for minus 1 in the exponential form either plus 1 or minus 1. When we are getting plus 1 and when we are getting minus 1, you see minus 1 whole to the power of 1, minus 1 whole to the power of 1, minus 1 whole to the power of, sorry, minus 1 whole to the power of 2, that is minus 1 whole square, minus 1 whole to the power of 4. If you observe here 2 and 4, what are these numbers? 2, 4, 6, 8. These numbers are known as even numbers. For minus 1, if even powers are there, even exponents are there, we get always plus 1. We get always plus 1. Similarly, if you observe for minus 1, 3 and minus 1 whole to the power of 5, we have odd numbers are there, 3, 5, 7. If minus 1 whole powers are odd numbers, we will get minus 1. We will get minus 1. Now, minus 1 whole to the power of any power, if it is there here, I will write here n. N represents what? 1, 2, 3, 4. If n is an odd, n is an odd number, then minus 1 whole to the power of n is equals to what we get? Minus 1 will get. When it is an odd number, n will get minus 1. If n is an even number, then we get minus 1 whole to the power of n is equals to plus 1, or simply it is 1. So this one you should remember. Now we studied about these exponents and powers for numbers. Now we will study for the variables. What about these variables? A into a, we will write as what? A square. A into a is equals to a square, or a to the power of 2. Here a is called the base and 2 is the exponent. Similarly, a into a, we will write it as what? A cube. A to the power of 3, a cubed. Here a is the base and 3 is the exponent. And a into a, we will write it as what? A to the power of 4. A to the power of 4. B into b, we will write as what? B to the power of 4. B to the power of 4. Similarly, x into x. So we will write as what? X to the power of 5. All these are what? Exponential form, where here a is the base and 2 is the exponent. Here a is the base and 3 is the exponent. A is the base, 4 is the exponent. Here b is the base and 4 is the exponent. And here x is the base, 5 is the exponent. Even not only for numbers, we also will write this exponential form for even for the variables also. Variables also will represent in the exponential form. Their products can be expressed in the form of exponents. Is it clear? Now we will discuss prime factors, prime factorization. Now we will discuss prime factorization, how to find the prime factors of a given number, and that concept also we will use in the exponential form. For example, prime factors of or prime factorization of prime factors of 4. 4 can be written as 2 into 2. 4 can be written as 2 into 2, that is 4 will divide with 2. 2 2s are 4 and remainder it is 0. So prime factors, prime means prime numbers, factors means the divisors which leaves remainder 0 are known as prime factors. See, for example, you take 4. What are the factors of 4? Factors of 4 are 1, 2 and 4. 2 is only one prime factor. As we know, 1 is neither prime nor composite, but 4 is a composite factor, composite number, therefore it is a composite factor. Here 2 is the only prime number and it is a factor of 4. Similarly, if you take prime factors of what it is 6, prime factors of 6, prime factors of 6 can be written as 6 means so we should divide with only prime numbers. So use here divisibility rules. Which is the first prime number? 2. Check whether it is divisible by 2 or not. What is the divisibility rule for 2? 2 means it is all even numbers are divisible by 2. It means that in the units place it should have either 0 or 2 or 4 or 6 or 8. Such numbers are divisible by 2. Otherwise they are not divisible by 2. Here 6 is there, it is divisible by 2. 2 3s are 6. And we'll get remainder 0. See, the last number 3 we got, it is also a prime number. Now prime factors of 6, it is 2 into 3. 2 into 3. So this can be written as 2 into 2 means it is 2 square or 2 to the power of 2 we will write. So this is 2 into 3 means it is 2 to the power of 1 into 3 to the power of 1 we can write it. Now what about other numbers? We will see here. Prime factors of 32. Prime factors of 32. So again 32 you see here. 32, so it is an even number, hence it is divisible by 2. Divide with 2. 2 1s are 2. 3 minus 2 it is 1. Then bring 2, it will become 12. 2 6s are 12. 2 8s are 16. 16 minus 16 it is 0. Then 8 is there. 2 4s are 8. 2 2s are 4. 2 2s are 4. See the last number what we got? 2. 2 is a prime number. So its prime factors it is 2 into 2 into 2 into 2 into 2. That is 2 to the power of 5. Again here we wrote here the exponential form. Exponent and base we used. Now I will say again what is the difference between factor and prime factor. What are the factors of 32? Factors of 32 it is 1 into 32, 2 into 16. Then 4 into 8. 4 into 8. So 1, 2, 4, 8, 16 and 32. All these are factors. They are factors. But here 2 is the only one number which is a prime number. Remaining all are that is except 1, 4, 8, 16 and 32 all are composite numbers. So here 2 is the prime number. So we can write 32 in the form of 2 into 2 into 2 into 2 into 2, that is 2 to the power of 5. 2 to the power of 5 is equals to what? It is 32. The exponential form of 32 it is 2 to the power of 5. Means 2 is multiplied by 5 times. Like this we will find the prime factors by using what? Divisibility rules. For 2, for 3 and for 5, 7 we use only prime numbers 2, 3, 5, 7, 11, 13 and so on. So using those prime numbers we will find the prime factors of the given numbers and we will expose those numbers in the exponential form. This is the about prime factorization. We will discuss this concept by solving some of the problems from the textbook. Now we'll see the exercise number 13.1. Question number 1. Find the value of the following. 2 to the power of 6 or 2 is raised to the power 6 and 9 to the power of 3 or 9 cube. See the first sum. 2 to the power of 6 means 2 is multiplied by itself for 6 times. How many times? 6 times. So write 2 into 2 into 2 into 2 into 2 into 2. That is equal to, write 6 times and multiply. 2 into 2, 4. 4 into 2, 8. 8 into 2, 16. 16 into 2, 32. 32 into 2, it is 64. 32 into 2. 2 2s are 4. 2 3s are 6. We'll get 64. So then 2 power 6 is equal to how much it is? 64. Now the second sum. It is 9 to the power of 3 means 9 is multiplied by itself for 3 times. That is 9 into 9 into 9. 9 9s are 81. 81 into 9 multiply. 81 into 9. 9 1s are 9. 9 8s are 72. So how much it is? 729. 9 cube is equals to 729. This is exponential form. For this exponential form, that means 729 can be written as 9 cube and 64 can be written as 2 to the power of 6. Now express the following in the exponential form. Here it is given the expanded form. That expanded form we should write in the exponential form. How to write this exponential form? See the first sum. It is 6 into 6 into 6 into 6 into 6. 5 times 6 is multiplied. 6, 1, 2, 3, 4, 5. 5 times 6 is multiplied. Therefore, it can be written as 6 to the power of 5. 6 to the power of 5. Now, the third sum. It is b into b into b into b. That is, b is multiplied by itself for 4 times. 1, 2, 3, 4. Therefore, it can be written as b to the power of 4. b to the power of 4. Next, this sixth bit from that exercise. That is a into into c into c into c into c into d. See here, 3 variables are there. A is one variable, C is one variable and D is one variable. All are different variables. So A is multiplied by itself how many times it is? It is multiplied by itself, it is how many times? 3 times. Therefore A into A can be written as a cube into. Next C is there. C is multiplied by itself for 4 times. C into C into C into C. Therefore it can be written as C to the power of 4 into. Then D, we have only one D is there. We will write it as D. Now this can be written as A to the power of 3 into C to the power of 4D. A cube into C to the power of 4 into D. Short form we will write like this. So this is the exponential form for A into A into A into C into C into C into C into D. Like this, for expanded form we will write in the exponential form, and exponential form we will write in the expanded form, and we will simplify. Thereby we can find its value. I hope you understand how to write the given numbers in the exponential form. Now we will discuss third bit from exercise number 13.1. Express the following numbers using exponential notation, exponential form. So 512 and the other problem it is 3125. So how to write 512 in the exponential form? So I told we should find prime factors by using the prime factors concept. So what are the prime numbers? 2, 3, 5, 7. Check. We start with the 2 small numbers. 2, 512. Whether this 512 is divisible by 2 or not. If it is divisible by 2, which numbers are divisible by 2? In the units place of a given number is 2, then such 2, 4, 6, 8 and 0 is there. Such numbers are divisible by 2. Otherwise, those numbers are not divisible by 2. Then use here we have in the units place we have 2 is there. Therefore, this number is divisible by 2. You divide with 2. So 5 is there here. 2 2s are 4. 2 2s are 4. 5 minus 4 it is 1. Then bring 1. 1 with 1 it is 11. So 11 means it is 2 5s are 10. 2 5s are 10. 11 minus 10 it is 1. Bring 2. You will get 12. 2 6 are 12. So 256 is the next, it is a dividend. So again 6 is there in the units place. So it is divisible by 2. So divide with 2. 2 1s are 2. 2 minus 2 it is 0. Bring 5. 2 2s are 4. 5 minus 4 1. Then bring 6. 1 with 6 it is 16. 2 8s are 16. Now again in the units place we have 8 is there. So it is divisible by 2. 2 6 are 12. 2 4s are 8. 2 4s are 8 and remainder 0. Again we have here 4 is there in the units place. Therefore it is divisible by 2. 2 3s are 6. 6 minus 6 it is 0. Bring 4. 2 2s are 4. 4 minus 4 it is 0. Now 32. Again 2 is there here in the units place. So it is divisible by 2. 2 1s are 2. 3 minus 2 it is 1. Then bring 2. 12. 2 6 are 12. 16 2s are 32. So again 16 we will get in this 2 table. 2 8s are 16. 8 2 4s are 8 and 2 2s are 4. See that last number we should get a prime number. We should get a prime number. Therefore 512 can be written as what it is? 2 into 2 into 2 into, how many 2s are there? 1 2 3 4 5 6 7 8 9. How many 2s are there? 9. So 2 into 2 into 2 into 2 into 2 into 2, like this will write. So what it is? How many 9s are there? 1 2 3 4 5 6 7 8 9. Therefore it is 2 to the power of 9. 2 to the power of 9. 512 is equals to 2 to the power of 9. Now it is 3125. 3125. How to write this? 3125. So check for 2. What is the divisible rule for 2? Units place we should have either 0 or 2 or 4 or 6 or 8. Here we have 5 is there. Therefore it is not divisible by 2. Next, what is the prime number? It is 3. Check whether it is divisible by 3 or not. What is the divisible rule for 3? It is sum of all the digits of a number. Sum of all the digits of a number. If it is 3 or a multiple of 3, that number is divisible by 3. Otherwise it is not divisible by 3. That is add the digits. 3 plus 1 4. 4 plus 2 6. 6 plus 5 it is 11. 11 is not a multiple of 3. Therefore this number is not divisible by 3. Next number, it is prime number is what? 5. What is the divisible rule for 5? The divisible rule for 5 is if the units place digit of any number is either 0 or 5, then such numbers are divisible by 5. So here in the units place we have 5 is there. Therefore this number is divisible by 5. So divide with 5. 31. 5 6 are 13. 31 minus 30 it is 1. Then bring 2. We will get 12. 5 2s are 10. 12 minus 10 it is 2. Then bring 5. 25. 5 5s are 25. Again you check here it is. It is not divisible by 2. 6 plus 2 8. 8 plus 5 it is 13. 13 is not a multiple of 3. Therefore it is not divisible by 3. So you test with 5. Again in the unit space we have 5 is there. Therefore it is divisible by 5. That is equals to 5 ones are 5. 6 minus 5 it is 1. Bring 2. Then you will get 12. 5 2s are 10. 12 minus 10 it is 2. Then bring 5. 25. 5 5s are 25. Again in the units place we have 5 is there. So it is divisible by 5. 5 2s are 10. 12 minus 10 2. Then bring 5. 25. 5 5s are 25. Again 5 is there in the units place. It is divisible by 5. 5 5s are 25. See that the last number we got 5 a prime number. So this is prime factorization of 3125. Therefore 3125 can be written as 5 into 5 into 5 into 5 into 5. That is 5 to the power of 5. 5 to the power of 5. So like this we will express the given numbers in the exponent using the exponential notation or exponential form by using the concept of prime factors, prime factorization. So you should check with only prime numbers like 2, 3, 5, 7, 11, 13, etc. etc. I hope you understand how to express the given numbers in the exponential form. Did you understand? Yes, it is clear to you. I hope it is clear to you. So what it is? Prime factorization. Now the homework, if it comes to the homework, textbook, exercise number 13.1, question number 1, third and fourth bit, question number 2, second, fourth and fifth bit, question number 3, second and third bit. Along with this, from today's class, write all the key points which we discussed in this video or in this class, in the classwork. I hope you understand this class. Thank you very much.